Hello there, folks. How's it going? Good evening. This is Mike coming at you with another video on Foundations of Math 2. In this video, we are going to get into some more word problems, but we're going to talk about certain words or certain phrases that sort of trigger certain operations to be done and what those things are and how we use them in taking words and sentences and translating them into mathematical expressions. So as you can see here, we have certain words and certain phrases that indicate certain operations. To sort of hint that we want to add two quantities, if we had some number like 10 more than a number, or a number plus some quantity. Those are the two most common ways that we would sort of trigger the thought of, okay, I need to add these two things. So some quantity more than a number or something plus something else. And that's the way we typically put the notion of adding two things into a sentence. If we want to get subtraction in a sentence, we'd say some quantity less than a number or some quantity less than some other quantity, or we'd say a number minus something. So less than or minus are the two words that we would typically use to describe a subtraction. And then division or multiplication, if you say twice a number, or 3 times a number, or 5 times a number, or if you say 1/5 of a number, that can be multiplication or division. That all just depends on what you are multiplying by. If you say a number divided by some quantity, like 4, or if you say a number times, instead of divided by, a number times 4. Those things are the sentence cues to say, okay, we're multiplying or we are dividing here. So let's take combinations of these things and let's take a portion of a sentence and write it as a mathematical expression here. 5 times a number plus 4. Now, in all these examples here, you've seen this thing, a number. This number is sort of unknown, so we can give it any name whatsoever. But typically, the letter that we use to stand for these things that are not known is the letter X. So we're going to let the letter X stand for this number, whatever it is. So if you just read this statement here, 5 times a number and then plus 4. So 5 times a number, I'm going to do 5 times this number X, whatever it is, and then plus 4 after that. So I'm going to add 4 onto that quantity there. So this is all we are trying to do here. We're just trying to take a sentence or a portion of a sentence and see how do we take the words and what the words mean actually and express it mathematically. Next we have 1 less than half of a number. So reading this very, very carefully, and you do have to perhaps think about this just a little bit. Think of the order in which you have to do these things. It says 1 less than half of a number. So I have this number X, whatever it is. I want half of that number. So I'm going to divide that by 2, or same thing as multiplying X by 1/2. It does the same thing. And then we want 1 less than this. So I'm going to subtract 1 from this thing here then. So I have X over 2 minus 1. So I'm going to challenge you guys, try this third one on your own here. 10 more than 1/8 of a number. Press pause now, see if you can figure out what the mathematical expression is going to be for this guy. And once you think you have the answer, press play and we'll see if you were correct. All right, so let's see if you came up with the correct answer. 10 more than 1/8 of a number. Well, I need to deal with the 1/8 of that number first. So my number x, I can multiply x by 1/8, or that's the same thing as taking the number x and dividing it by 8. And then it's 10 more than this thing, so I'm going to add 10 onto it. The other way you could have written this is 1/8 times x plus 10. Those two things are saying the exact same thing there. 1/8 times x plus 10. So this was just some basic practice with taking portions of sentences and writing them as mathematical expressions. Now let's actually solve some problems. You'll be seeing things like these, but these things will be equal to something, and you'll have to figure out what is that number. What is that x value that we've just been throwing in here but not actually solving for yet. So here's a couple basic yet very common samples of that. If 5 less than 6 times a number is 115, then what is our number? Now, one more thing that is very basic that you'll want to know before we go on to actually solving these kinds of problems. The word is here is basically the mathematical equivalent of the of saying is equal to or equals or just the equal sign. So what this is saying is if 5 less than 6 times a number equals 115, then what is our number? What is this x value that we're going to have? So let's take this thing right here and let's write it as a mathematical expression. 5 less than 6 times a number. So I have my number x. I need 6 times that thing, and then I need 5 less than that. So I need to subtract 5 from that thing. And I know that this is equal to 115, and now I just need to solve for my x value. So what I have to do here now is I have to get x all by itself on one side of this thing. So the way we do that, this may be more of a review for some of us. For some of us, this may be something you hadn't done in some time, a long time. So I'll go through it in some detail here. When you're solving for x, you want to get x all by itself on the one side. So here we have the x being multiplied by the 6, and then here we are subtracting this number on the end. What I need to do is I need to get this number over to this side first. And what I do to one side of my equality, I have to do to the other side so that it does indeed remain equal. Basically, I want to make this minus 5 vanish. So the way I'm going to do that is I'm going to add 5 onto that side. But like we just said, what we do to one side, we have to do to the other. So I'm going to add 5 onto both sides. Those are going to vanish. I have 115 plus 5. My left-hand side still has that 6x. So 6x equals 120. And now I have 6x equals 120. Now when you only have a number being multiplied by your x, when you solve for the x value, you just have to divide both sides by the number that is in front of your variable x. And then when you do that, those common factors of 6 cancel out, and x is equal to 120 over 6, and 120 over 6 is equal to 20. So there we go. That's our answer. Our number that we started with is going to equal 20. Do one more here. This one a little bit more fun, a little bit more hitting home for all of us right now, maybe. Just the general context of the question. I mean, here, considering it has to do with scores on tests, not so much the actual test score, but just the general content and topic of this question here. So a student gets a test score such that if he triples it and then subtracts 17%, he'd have a perfect score of 100%. What was the student's test score? So in all the other problems we've seen, it was a number. In this case, the question says the student gets a test score. Test scores are numbers, such that if he triples it and then subtracts 17%, he'd have a perfect score of 100%. What is the student's score, aka what is that number? So this test score here, we can just say that that's x. Now, what are we doing with this x value? The problem says if we triple it, so we're multiplying it by 3. So if I take x and I multiply it by 3, and then we subtract 17%, he would then have a perfect score of 100%. Saying he'd then have a perfect score is the same thing as saying that equals 100%. So 3x minus 17 is going to equal 100. And now we do just like what we did in the previous problem. We're going to solve for x. First thing I'm going to do is get rid of the minus 17 that's on this left-hand side. And I'm going to do that by adding 17 to this side. But what I do to one side, I have to do to the other. So that gives me 3x is equal to 117. And now, just like in the previous problem, now we just have a number times our x here. To solve for x, divide both sides by that number that's in front of x. The 3's cancel out, and I have 117 over 3. And if you plug that into your calculator, you get 39. So the student's test score was a 39%, which is not as good as he probably would have hoped. But this is the big idea in this section here. Taking word problems, taking phrases or single words and translating them into mathematical quantities, mathematical expressions, or mathematical equations. The things we had in these last two previous problems that we did. And then solving for the number or the quantity that we had to solve for. So these are very kind of basic, very low level types of things. These are things we'd see in basically everyday kind of life, but still very, very important to know how to do. guys, that concludes this video. If you have any questions or comments, please be sure to reach out to me. Send me emails, send me texts, phone calls, SOS bonfires, flare signals, whatever you have to do. Otherwise, until the next video, take it easy, guys.